Good day, teacher and classmates. We are the fifth team and we talk about the CNN or convolutional neural networks, specifically about the last layer, classification layer. All of us know that the neural networks have changed the landscape of data processing, giving us a tool and a clear view of this process. As a proof of this, we have the processing and creation of image through artificial intelligence or algorithms for data selection and information discrimination. One of these systems is convolutional neural networks. These have completely changed the landscape of image processing, allowing us to generate complex applications more simply and quickly. Therefore, they have become a fundamental tool in areas such as computer vision, facial recognition, object detection, and image classification. To better understand the above, we have to explain several concepts. One of them being, what is the CNN? Okay, the CNN or convolutional neural networks are a type of deep learning model used primarily for processing and analyzing visual data, such as image and videos. They are a special kind of neural network designed to automatically and adaptively learn spatial ranges of features from input data.
Everyone, let's start by understanding how convolutional neural networks, or CNNA, CNNA are designed to process data with a real-life topology. This is perfect for analyzing images, which are made up of pixels arranged in a grid. Their architecture is composed of multiple layers, and in each layer plays IK uh, IK role. This layer allows the network to automatically and hierarchically learn patterns and features from the input data. For example, early layers might detect simple features like edges or colors, while deeper layers can identify complex patterns like face of objects. This step-by-step learning is what makes CNNA so effective in things like images, classification, or object detection. Now, let's look at the main function of CNNA. So here, the first is the input layer. This is where an image is saved as a matrix of pixel values, include age, weight, and color channels. Use RGB. And next is the convolutional layers. These are layers use filters or kernels that scan over the images to detect important features like edges or texture. There should is a vector map showing where shows features upper. The common the polishing polyc layers. These restrict the size of the vector map while uh, keeping the most important information. The most common method is max polling, which allows the highest value in region. This helps to reduce the computational cost and prevents overthinking. And as shown in the diagram, CNNA can classify a wide range of objects or be fine-tuned for specific things like detecting COVID-19 or pneumonia uh, or detect pneumonia in medicines.
I will speak about the history of CNNs, okay? And the first step was in the year 1958. In that year, Franz Roosevelt develops the perception, the first artificial neural model, foundation for neural networks. That was the first step and was the base to the things that we're going to be later in all the work about CNNs. The next step was in the year 1988. In that year, Kishimoto Fukushima was a Japanese man. He proposed the neo connection to precursor to CNNs, introduced concepts like local receptive fields and hidden layers. In the year 1989, was the first sensor architecture that was created. Jan LeCun created the LEDNet 1, later improved as LEDNet 5 in the year 1998, used for handwriting digit reconnaissance for the Ministers data set. So, the next year or the next step in this history is in the year 1998. Okay, the LEDNet Fire LED come at that is the published and the architecture that become a classic CNN model. So use an early banking systems to read checks. In the year 2012, Alex Krikznechki, Yela Susketsky, it's a guy Russia, I think. Hilton win ImagineNet competition with AlexNet, so he performance using really you. And in 2016, this net and mobile net design future use via dense connection mobile net lightweight CNS for mobile and devices. So in the actually in the 2020s the CNS is a multimodal and real-time AI CNS adapter at the video 3D visions and combined with LLMs. So in basically the main is large language models. So using himself driving cars, medical imaging, AR, VR, that a lot of technologies we can use thanks of the CNS.
I'm going to talk about some of the most important benefits offered by artificial intelligence, also known as AI. The AI is transforming many sectors, such as industry, logistics, customer service, and even scientific research. During this presentation, I will explain three main advantages. The first is increased efficiency. The second is 24/7 availability, and the third is faster problem-solving capabilities. Now, let's begin with the benefits of AI. First, let's talk about efficiency. Artificial intelligence can automate repetitive tasks and processes that would normally take a lot of time if done by a human. For example, in factory, AI can control an assembly line, making sure everything works properly without interruptions. This saves time, reduces human errors, and boosts productivity. I can also be applied in logistics, for example, automating delivery routes or in customer service, such as chatbots that can answer basic questions without human intervention. And in 24/7 availability, we have one the bigger difference between AI and human. This that AI can work 24 hours a day, 7 days a week without needing to rest. While we need to sleep, eat, and take breaks, AI can keep operating non-stop, which allows companies to provide continuous service. This is especially useful in areas where time is critical, such as technical support, digital platforms, or customer service centers. Imagine some needing help at midnight. Thank you to AI, they can get instant answers without waiting for business hours, faster problem solving. Another great advantage is that AI can solve complex problems much faster than humans. It can perform calculation, run simulation, analysis data is used seconds. Tasks that would take a human hours or even days. This is especially important in fields like scientific research. engineering, and medicine. For instance, AI can analyze millions of medical records to find patterns that help detect diseases or predict outcomes. In engineering, it helps simulate structures, optimize designs, or detect faults before they occur. In conclusion, artificial intelligence offers many benefits that were once unimaginable. It increases efficiency by automating tasks. This is available 24/7, and it solves complex problems much faster than we can. Also, there are still ethical and technical challenges. There is no doubt that AI is changing way we work, research, and life. Thank you.
layers extract. The high level of features from an image, the classification layers interpret those features. Here is what they do. The first one is they flighted the future maps into a one-dimension vector. In that case, is the 1D vector. This is for the image, only on the image, because we need the application of CNN is only for image. And then the assign probability of each class. This is one of the probability to make another example for this application. And finally is output the final result on the network, the predicted class or label, the act and decision making of part of the CNN. This is one of the applications we put in this presentation because it's one of the most important things we need to talk about this kind of signature of uh, this kind of technology we are talking about. An application of CNN layers. This is one of the most important things in the CNN. We're talking about the image classification. One example is telling the difference between a cat and a dog photo. This is one of the most important things of this technology. The medical image imaging. One of the example is detection tumors in X-rays or MREAS. This is one of the medical assignments, and we put this example because it's one of the most I don't know. This is one of the most eccentric use for this type of technology. Another is the autonomous vehicles. The autonomous vehicles are one of the examples are the classification traffic signs or identifying the pedestrians. This we can help them because in we try to when we try to find in the internet information or another type of documents, we have an advisement for the robots or something else, and the algorithm tell us to select all the I don't know, all the vehicles or the cycles or include the traffic lights, and we select that information and we help that algorithm to make a more I don't know, to make more easy for them to identify all these things, the security and surveillance. The example is identify unauthorized persons or objects. This is from, I don't know, security in a a private establishment or in a company. We need to we need to have only certain people, and these certain people we need to enter in the building, and we need a system to identify all these people. Industrial automatization. The example is classification of objects in products. This is one of the most important things we need to do in our career, and this is one of the most common use of this technology in the industrial workers, and we try to do much. There is a lot of examples of about this type of technology. And the last, the conclusion. The conclusion of this type of technology are about so many types of use, and the convolutional neural networks are one of the most powerful and wide used deep learning models, especially for working and visual data. The ability to automatically learn special features from image from them and learn about the futures from image make them ideal task